Hello dear friend, I am Professor Dinesh Kulle and today we will study the angle of acceptance and numerical aperture. Now dear friend, concentrate on the first figure. This is a core and cladding. This is part of optical fiber. The optical fiber is made up of three parts: core, cladding and outer jacket. Outer jacket used for to protect the optical fiber from the surrounding. Now listen, this is core. We will say that suppose N1 is a refractive index of the core and N2 is a refractive index of cladding. Refractive index of core is always higher than refractive index of the cladding. Now listen, suppose the ray of light coming from the surrounding enter in a core. Suppose this incident angle, we will say that theta suffix I, and the refractive index of the core is higher. That's why the ray of light bend toward the normal. Okay. Now this is refracted angle. We will say that the theta 1. Refractive index of the surrounding means n suffix 0. We will say that from the air, suppose at air. So the ray of light coming from surrounding to the core, that time it bend toward the normal and refracted angle is theta 1. This is the interface between the core and cladding. We draw the normal at the point of incidence, and this is theta 1 and this is 90 degree. That's why this is 90 minus theta 1. This is simple geometry. Now suppose as we vary the incident angle, then theta 1 also varies, which is affecting on this incident angle between the core and cladding interface. This angle is vary also. So we adjust this incident angle as possible as this incident angle at the core and cladding is equal to the critical angle. Then and then what happened? Ray of light is refracted with the 90 degree. It means that this incident angle means 90 minus theta 1 is a critical angle. But at the same time, the corresponding incident angle is called as angle of acceptance. So we will say that this theta I is equal to theta suffix 0. We say that angle of acceptance. Now dear friend, how to make the sentence the angle of incidence of a light on a core? This is the angle of incidence. Angle of incidence of a light at the core from the surrounding, at which the angle of incidence at the core and cladding interface is a critical angle, then corresponding incident angle is called as angle of acceptance. What is the meaning of it? Why we say that the angle of acceptance? Dear friend, as we decrease this angle, then this angle also affecting. So this critical angle also changes, means the angle is vary and then the ray of light is internally reflected. But this is the maximum angle at which the ray of light is refracted with the 90 angle. So that's why we will say that angle of acceptance. Okay, it means that suppose as we increase this incident angle, then refracted angle also changes and there is no possibility of total internal reflection. That's why we say that acceptance, angle of acceptance. यानी कि अगर इंसिडेंट एंगल हम चेंज करते हैं, बट एन ऑब्वियस रिफ्रैक्टेड एंगल भी बदलता है, और कोर एंड क्लैडिंग का जो इंटरफेस है, यहाँ जो इंसिडेंट एंगल है यानी 90 माइनस थीटा 1 ये भी चेंज होगा. जब इंसिडेंट एंगल कोर एंड क्लैडिंग का क्रिटिकल एंगल जितना हो, यानी कि रिफ्रैक्टेड एंगल 90 डिग्री हो, तब जो इंसिडेंट एंगल रहेगा सराउंडिंग से कोर तक, उसको हम एंगल ऑफ एक्सेप्टेंस बोलते हैं। यानी ये जो नॉर्मल है और एक्सेप्टेंस एंगल, इसके बीच में जो भी एंगल रहेगा इंसिडेंट एंगल का, जो भी रे ऑफ लाइट आएंगे वो ऑप्टिकल फाइबर में से पास होंगे, यानी उनका टोटल इंटरनल रिफ्लेक्शन होना पॉसिबल है। बट जो एक्सेप्टेंस एंगल से ज्यादा उनका इंसिडेंट एंगल रहेगा, वो रे ऑफ लाइट ऑप्टिकल फाइबर में से पास नहीं होते। इसलिए ये जो मैक्सिमम एंगल है उसको हम एंगल ऑफ एक्सेप्टेंस कहते हैं। नाउ डियर फ्रेंड, everyone got the idea what is acceptance angle. Now acceptance cone. Now everyone got the idea, this is the acceptance angle and the cone is formed, for example this angle, this angle. Okay, this is also acceptance. यानी जो भी रे ऑफ लाइट इस रीजन में एंट्री करते हैं ऑप्टिकल फाइबर में, इस रीजन में या इस रीजन में, वो ऑप्टिकल फाइबर में से पास हो सकते हैं, पर इससे ज्यादा और इससे ज्यादा जो भी एंट्री करेंगे इस रीजन में, जो एंट्री करेंगे वो ही जा सकते हैं। अगर यहां से लाइट आता हो तो वो ऑप्टिकल फाइबर से पास नहीं हो सकता। नाउ एक्सेप्ट, ये जो कोन फॉर्म हो रहा है, ये दिस इज एक्सेप्टेंस कोन. This is very simple concept. So this is acceptance angle. This is also acceptance angle. अगर ये ऐसा जो कोन फॉर्म हो रहा है उसको हम acceptance कोन कहते हैं. Now dear friend, we will solve the derivation related to angle of acceptance and numerical aperture. Now this is the incident angle. This is theta 1, interface between the surrounding and core. We will say that this point is A and this point is B, which is interface between the core and cladding. This angle is 90 minus theta 1. According to our previous discussion, angle of acceptance, this is the angle of acceptance. That time refracted light between the core and cladding interface is 90 degree. Now we apply the Snell's law for the point A. So using Snell's law at point A, so refractive index of this medium is n suffix 0 and incident angle is sine of 0 equal to refractive index of core n1 and refracted angle is sine of theta 1. So we got this relation. Now sine of theta suffix 0 is equal to n1 upon n suffix 0 sine of theta 1. So we will say that this is equation first. Now concentrate on the point B. Concentrate at, so at a point B, so refractive index of core is n1, corresponding incident angle is sine of 90 minus theta 1 is equal to refractive index of second medium and corresponding refracted angle is 90 degree. Means refracted with the 90 degree. Now dear friend, but sine of pi by 2 minus theta 1 is equal to cos of theta 1 and sine of 90 degree is equal to 1. So above equation become n1, this is cos of theta 1 is equal to n2. Now, so cos of theta 1 is equal to n2 upon n1. From the equation number 1, here the sine of theta 1, but here the cos of theta 1. That's why this last equation we will convert in the form of sine. So sine of theta 1 is equal to root of 1 minus cos of theta 1 square. So sine of theta 1 is equal to 1 minus cos square theta 1 means its value is n2 square upon n1 square. So sine of theta 1 is equal to root of n1 square n2 square upon n1 square. So finally we got sine of theta 1. So we will put this value in equation number 1. So from equation number 1. So what is the equation number 1? Sine of theta suffix 0 is equal to n1 upon n0 sine of theta 1. So above equation become, so equation 1 become sine of theta suffix 0 is equal to n1 upon n suffix 0, and this is the value root of n1 square n2 square upon n1 square. Now this n1 square root of n1 square, it means that n1. So n1 n0 n1 root of n1 square n2 square. So this n1 get cancelled. Sine of theta suffix 0 is equal to 1 upon n suffix 0 root of n1 square n2 square. But dear friend, n suffix 0 means refractive index of air is 1. That's why sine of theta suffix 0 is equal to root of n1 square n2 square, and this is nothing but numerical aperture. Means acceptance angle means theta suffix 0, and sine of acceptance angle is called as a numerical aperture. We got this relation, sine of theta suffix 0 means numerical aperture is equal to root of n1 square, which is refractive index of the core, minus n2 square means refractive index of the cladding. In this way we can solve this derivation. Now the next, sine of theta suffix 0 means numerical aperture is equal to n1 square minus n2 square. This is the relation. But if theta I means incident angle should be less than acceptance angle, then sine of theta I is less than sine of theta suffix 0. It means that sine of theta I is always less than numerical aperture. So in this way, we have to complete the derivation of angle of acceptance and numerical aperture. Thank you.